Hi, and welcome to the Agile in Action podcast with Bill Raymond. Today, I'm joined by Paolo Sammicheli. Paolo, how are you today?
Oh, I'm great. Thank you, Bill.
Wonderful. We are going to talk about scaling AI product teams with Scrum, popular topic right now. Paolo is a registered Scrum trainer in Italy, author of Scrum for Hardware, and also author of Scrum in AI, which is going to be the topic we converse about today. Before we get started, Paolo, could you share a little bit more about yourself?
Thank you, Bill. So I've been working on, let's say, digital world for a little bit more over 30 years. The first 20, I was developing software like probably almost everybody in the agile space. And then the last 10 years, I moved silicon to carbonium. So meaning from the telling machine what to do to try to help human beings in being more productive at work. And so my first and the big love is Scrum. And I've been lucky enough to work on companies of different sectors and different markets and different industries. So I worked in a software company, traditional software company. I worked with marketing and digital ads. And then I had the opportunity to coach hardware companies, so industrial manufacturing, oil and gas, construction and engineering companies, automotive, and later pharma. And even today, I'm working with companies mainly on the industrial part. So my journey started with hardware. So hardware meaning a product that is tangible that might contain some software, since the software is everywhere today, but also contains some electronics so that the software can work, the mechanical parts, the plastics, and so on. This gave me a little bit of need and desire to go and understand the root of Scrum, and that's how I end up working with Jeff Sutherland and the Scrum Inc. and teaching for them. And the pandemic came. And so that's where I had the opportunity to stay at home for a little bit and learning more about something I was passionate since many years, AI.
And we're going to be talking a lot about how teams can work together building AI. But I guess AI is this generic term that a lot of people throw around. There's machine learning, there's large language models, there's all these different terms in the market space. But specifically, what are we going to be talking about today when you're talking about working with AI in Scrum teams?
Yeah. So I would like to open with a joke. I'm an Italian funny man. And what's the difference between AI and machine learning? So if you want to work with machine learning, then you probably need the Python. If you want to work with AI, probably you need the PowerPoint. So basically, AI is the fancy and the like more marketing name for something that more specific. So the machine learning, so creating algorithms, making the machine learning by itself through the data, it's the topic I covered in my book. Today, after the advent of ChatGPT, everybody is focused on a very narrow part of the machine learning that is called the large language model. The stories I've included in my book that I published before ChatGPT are about people building applications on top of machine learning algorithms, or better, machine learning models, we should say. And especially specifically in one long story, it's about a client of myself in pharma, but also I mentioned other clients like in banking and so on.
So we're going to be talking about building AI models. I guess the big question that I would have is, and maybe our listeners might have, is what is a model in this context?
Yeah. So if you want to develop a software, traditionally you use the programming language, and basically you using this language, you tell the machine what to do. So you write the algorithm and then you provide the input and you get the output from the machine. That's the traditional way of developing software. Now, through this kind of empty structure that in some way try to mirror how the human brain works, called the neural networks, you provide the machine the data and you provide some example of how the output should be. And with this process called the training, the machine learns what are the characteristics of the data to produce that kind of output and learn the algorithm by itself. So, an example might be if you want to build a simple algorithm to recognize dogs for cats in pictures, you provide multiple pictures and you say, okay, this is a dog, this is a cat, this is a dog, this is a cat. After a while, if you provide a new picture the machine had never seen before, then can say, okay, this is according what I know, 90% a dog and 10% a cat. So this is machine learning. So if we talk about the traditional development, we talk about algorithm. These are not really algorithms, are more like heuristics. So we call it model because it's basically an executable part that comes from data. So it's modeling the data. That's why they are called models.
So I think I understand when we write software code and let's say we just want to perform some sort of a known function like 2 plus 2. Okay, you just create some sort of a math function in software code that adds 2 plus 2, and software has been able to do that for the better part of our lives. And now what we're saying is we don't necessarily know what the result is because if I feed an image of a dog to a computer, it doesn't necessarily know what a dog is. So you train it and you have a model that has these images of dogs. And somewhere is in the background being trained is a model that has lots and lots of pictures of dogs. So that when you do send a picture of a dog, it says, I know that this is a dog for these reasons. And it finds these characteristics. So it's much more than a 2 plus 2 problem. It's a prediction. The system is figuring out how to do that, not the programmer, if you will. Is that what you're saying?
Exactly. And also the trick part is that you provide the data and you hope that this will create the model you expect, but you can't know in advance the result until you try it. So basically, training a machine learning models is an empirical process because you have to continually inspect, adapt, and basically you stop when the result is good enough because there is no perfection. Of course, there is no perfection also in traditional software. Unless you do something very simple, it's impossible to have a bug free code. But with machine learning, it's even more probabilistic rather than deterministic. So you think that in most of the case, the model will perform as expected. But in the development process, you understand if works or not through testing, basically. So you start with a set of data, you keep for yourself a subset of these data, and then after the training, you use this subset that you didn't provide to the machine to check if the model is performing as you expect. And so it's empiric. And guess what else is empiric? Scrum, of course. So that's how my client came to the idea of let's use a Scrum and approached me asking me, can you help us with this AI development?
Yeah, and that's what I wanna get into, but I guess I'd like to understand from a team perspective, if you think about your typical software development Scrum team, and then think about what an AI team might look like, what are some of the differences? What might we expect to see differently?
In Scrum, we have a team defined as a cross-functional. What means cross-functional? Means that all the skills necessary to build the product, the increment called the Scrum, stay within the team. So the developers combined, they possess all the needed skills to build the increment. Now, when you have trained the machine learning model, of course, you need somebody that knows about the technical part, how to set up the neural network, how to choose the right one, and so on. But also, you have to have the data. And in most domains, understanding the data is something very far from the competencies, the skills of AI. If in a software team, you normally have a certain number of skills, the standard dev team in software might be a front end, a back end, somebody about data, somebody about systems, but I don't think it would be more than 6 or 7 different skills. When you have to work with these models, On top of the software people, you need a domain expert. So if you have to train a model to recognize cat and dogs, probably you need somebody expert in cat and dogs. Now, almost everybody is expert in cat and dogs because it's quite a similar knowledge. What if you have to build some models, very specialistic medical models to recognize an X-ray if there is some disease, for example, on X-ray picture recognize if there is a cancer or a broken bone, or you need the doctors. So the skills between the Scrum AI team tend to be more and more diverse, and so also the language and the jargon will be more diverse between these people.
Yeah, and what I understand too, because I did learn how to write some very basic models while I was also sitting through the pandemic with extra time on my hands, shelter in place specifically. I did learn how to create some of these, and it's very interesting. Even if you think we have this database and we can just feed it into this AI system, no, you can't. You really need to think about how the AI system is going to use the data, and there's a lot of various things that you need to do to get that data accurate. And then I think also, if we look at this from a larger company perspective, if you want to have some sort of a AI system in your organization, it could cut across business units. So now not only do you need data scientists and experts in the data, you might be bringing databases together that you never did before, and that's work. That the bringing together of the databases might be your typical skill set, but all this upfront work of understanding how the model needs to be trained, the science behind it, and the domain knowledge, that's pretty significant, isn't it? That's a big change to a software development team.
Yes. And then also depending on the how sensitive are these data,
Mm.
because my clients, they are multinational, they have data all around the world, and a kind of data that might be in banking, that might be in medical field, of course, that data about the US citizen cannot leave the US. Data about the European citizen cannot leave the European Union. Data about the Chinese, I mentioned it, three systems that are not allowing to export sensitive data. So you have a lot of challenges like masquerading the data so that you remove the relation between the data and the real person. And then but doing this, you have to maintain the significance of this data. And so the challenges are many, and they need to have kind of a teamwork mindset in companies. It must be necessary because if you have a company thinking in silos, this is my own data, this is your data, then the interesting part is correlating data that has never been correlated before. And so sometimes the problem is not even technical, it's more like political slash organizational. And in big organizations, that is from challenging to sometimes impossible, even though you stay within the same company.
It sounds like there's all this upfront work that needs to happen in figuring out how you're going to bring this data together and get it into the format that is required for the model and the legal aspects. And there's a lot more that goes into it, it seems. And then also, it does seem like maybe there could be more time required for this model to be built in order for teams to just jump right into a sprint. So, how do we get our arms around that? How do we think about continuing with this effective value delivery concept of Scrum and continue developing at a clip, at a pace that allows us to test and validate before we go too far and realize that we don't have a functioning product? What are some of the things that we need to change or be aware of in Scrum if we're going to do that?
Bill, you touched a very important point of this topic. Thank you. So basically, that's what many people think, right? Oh, I need the prepared data, curated data, reliable data. So let's have a first data preparation moment, or let's call it phase. And then when we have a data from different sources, then we can have a team developing the model. And then when we have the model, okay, let's have somebody building the application because that is a traditional software. And now what you get a Gantt chart where you have AI, then machine learning data, AI, and then software. And then when you reach the end, what is the biggest risk normally developing AI is actually developing something that nobody cares. I attended online a few classes of Professor Andrew Ng of Stanford University, one of the most appreciated professor in AI space. And he have this comic in his slide saying that there is like a group of developers saying our model perform very well on the test set. And the product owner says, but we haven't solved the business problem yet. And the developers answer, but we are performing very well in the test set. So the problem is that from beginning, how you know that the data is right, how you know that the way the model is producing the output is usable. You have to go all together. So the idea is what I've seen with these clients doing successfully is you need to build a team of all the needed skills. And this means having the domain expert, the data scientist, the machine learning engineer, and the software developers. Let's pretend that we can stick on less than 10 people. So we have only one team for a second. Okay. And what we do, okay, every sprint, we collect a little bit of data. And believe me, sometimes is actually domain expert copy pasting on a spreadsheet and exporting like a comma separated value file. It might be simple like that, but the understanding which data is significant to build the model, it's really a skill that is a domain expertise. Then if we have the machine learning engineer, the data scientist that needs to select the kind of machine learning architecture and try many way of training this model. And so I'm going to use some fancy term now for machine learning expert like hyperparameters and so on. So we have to tweak the model and retrain multiple times, comparing the different results to try to guess the best combination of these multiple parameters. Actually, this is so complex that some advanced solutions, they have a machine learning model tweaking the parameters of the machine learning model because it can be so time consuming for a human being that we need a machine to try to do that at the best possible way. And then you have to see if the result makes sense for the software part. So we want to develop something like an MVP or just a scaffolding so that we can already try to use this output. And then the feedback from the user perspective, is this data actually solving something we care? And then we repeat this kind of development continuously. So the AI solution basically is growing like a snowball when you throw it in mountains, right? The fascinating part is that if you ask a machine learning expert, they already say, okay, I need a little bit set of data. Let me do some experimentation. Then you can provide me more data. I will keep it experimenting. Then you provide me more data. So they are instructed at school to progress iteratively. So the thing is, let's put everybody together so that every time somebody have a problem, can speak with the other people and fix it on the fly instead of relying on long distance communication processes of inter-silos communication. But most importantly, you understand quickly the routes you are taking that are leading nowhere. And so you can change direction because sometimes you want the data differently. You want a different set of data, or maybe the data scientists might say that do not contain strong signals so that you can't from the data learn what you want to learn. So we need to change the approach, and that this is something you cannot be done in different moments and different silos. It needs to be done all together.
I am curious though, probably every team in any organization is working on some sort of an AI effort, probably building models or working with existing models and tweaking them. What are we going to do from a product management perspective? How do we make sure that we can look at this, if you will, outside of just the one Scrum team and we think about this at a scale?
The product ownership with this kind of solutions, it's even more challenging than in traditional software. It's quite challenging already. In software, we know that 20% of the feature of a software is used by 80% of the time. So by prioritizing what is more valuable can have a huge impact and have a tremendous return on investment, because in a very short time you can build something very valuable, or missing that 20%, developing something irrelevant, then you have features never used. According to research in early 2000, there was the Standish Group, Jim Johnson publishing these data, and then being these kind of researches have been repeated multiple times, but it's called the Pareto ratio 2080. In AI, there is a video of a conference of 2019 in San Francisco. And in this conference, I heard two people talking on a round table. There was this woman from IBM that was the vice president of artificial intelligence at IBM. And there was a guy, I don't remember the name, sorry, that was, I think it was VP AI and innovation, if I recall correctly, a Gap fashion brand. And during this conference, they shared some data about 87% of AI project never end in production. And this number is huge. Now, with ChatGPT and large language model, things are easier because you can iterate faster. But for those that are still relying on new models, they can just take a model off the shelf and just calling a simple API. The chance of building the wrong thing, it's very high. If we talk about a large language model for a second, basically every 2 weeks, at least every month, there is a significant news from the big players about something new in the large language model alone. And this is required very close collaboration between technical people in software, technical people in AI, domain experts, and also product ownership. That's why I insist in calling it product ownership and not management, because it's the same difference of restaurant owner or restaurant manager. So if you ask a restaurant manager to change dramatically the setup of the restaurant so that maybe it can get, I don't know, a Michelin star and get a lot of people attracted by this recognition, then maybe the manager does not have the delegation to invest a lot of money for these kind of things. You have to talk with the owner. So it was the same meaning of the restaurant owner talking directly to the staff and making decision quickly. So that's really the thing. When you build traditional software, you still need the product ownership because software is challenging. At the end, it's never been easy. But maybe for something you can stick on management, product manager. With AI, I think you just need the product owners. Period. Again, the Standish Group is very vocal on this. Decision latency is affecting project failure. So with a high decision latency, the chances of failure becomes very high. And so this is a KPI that should be considered when you set up an organization.
That's a really good thought there. And that's, I think, the power of agility and Scrum, right? It's because we do time box things and we test things and we make sure that we're delivering value. And it's okay for a team to say, this work that we put all this time and effort into ultimately won't be successful. And you can kill it before you spend too much money on it.
Absolutely. Also, very importantly, for people listening to us that have never seen, there is a very interesting video, very clever video. I would say something that is genius. Is a video called "The Product Owner in a Nutshell" by Eric Knieberg, and that is a condensed 2 days product owner class in less than 10 minutes.
Thank you. And I'll make sure that I share that video. If you're listening to this podcast, I'll make sure that I include that in the links that we'll talk about in just a few minutes. Before we wrap up, I'd love to know if there's anything that someone listening to this podcast can do right now if they want to start down this journey. Because I have to imagine there are people listening to this podcast saying, AI is either here and we're still trying to figure things out, or they know it's coming any day now. So they want to get ahead of things. What are some immediate things that they can do?
Before I mentioned, you might not have 10 people to cover these skills. Maybe you need more people, and that is scaling. So to scale properly, what I used successfully is Scrum scale, and particularly the Scrum patterns. So there is a very precious book that came out in 2019. It's called A Scrum Book, A Scrum Book, just like that, by Jeff Sutter and Jim Coplin. And there is a very large collection of Scrum patterns. So basically, you will find there some optional pieces of Scrum on top of the Scrum guide and build something more sophisticated to solve your challenges.
Mhm.
And in my book, Scrum AI, you can find it on scrum-ai.com. I talk about these patterns and I recap what a Scrum pattern is and how to use it. And we know that large teams, larger than 10 people, normally are very unproductive. It's hard to communicate. It's hard to do all the stuff. So what you want to build is a team of teams. So if a team is a set of individuals working together and helping each other in order to achieve a common goal, that is the team goal. A team of teams is a set of teams working together and helping each other in order to achieve the common goal, meaning the team of teams goal. Probably, if you have, unless you're developing something simple with just the large language model APIs, so that is AI, but it's not so complex. But if you have to train your own model, if you have domains like the one I faced in the pharma, for example, when you might have so many stakeholders and possible applications that you need to talk different jargons in different fields of medicine, for example, you will end up having too much work for a single product owner. And we used a pattern called the product owner team. So this is a variation of Scrum that is contained in this book, and that's how I solved this problem.
Okay, thank you. Paolo Sammicheli, how can people reach you if they want to further this conversation?
Well, LinkedIn is the fastest way. So I'm the only Paolo Sammicheli. Probably I'm the first one. And there is my website. So it's paolo.sammicheli. So just connect me and typing something in the introduction message like I heard you on the podcast with B. Raymond. And we can start talk. And I will happy to learn more from your challenges and your success as well.
Oh, that's wonderful. I will make sure that your LinkedIn link, your book, all of the recommendations that you made for other books and videos are all going to be on the agileinaction.com website. They'll also be in the show notes. If you're listening in a podcast app right now, just click the link that will bring you there. And of course, if you are watching the video on YouTube, just go ahead and look down at the description and you'll find that there. Paolo Sammicheli, thank you so much for your time today.
Thank you, Bill. Thank you for inviting me. Thank you, everybody, for listening.
Thank you for listening to the Agile in Action podcast with Bill Raymond. Subscribe now to stay current on the latest trends in team organization and agile techniques. Please take a moment to rate and comment to help us grow our community. This podcast is produced in affiliation with Cambermast LLC, and our executive producer is Riyama Dagason. If there is a topic you would like Bill to cover, contact him directly at bill.raymond@agileinAction.com.